In this example, in this video, we're going to do a molecular formula example. Now, molecular formula is looking at the multiples, and so your end answer could be reduced. There are two ways, two types of molecular formula problems. There is one that's very easy, and they give you the empirical and a mass, and you just solve for how many times the multiple. The second way is just more work, and it's not harder, but first you have to find the empirical, and then you will go on and figure out how many multiples this is. So this example that I'm giving you says find the molecular formula when the mass is 34 units and contains 0.44 grams of hydrogen and 6.92 grams of oxygen. In this problem, I'm not giving you an empirical, so we can't do the easy way. We're going to be doing the more work way, so we need to first find the empirical formula. So we will take the 0.044 grams of hydrogen and the 6.92 grams of oxygen ratios that they've given us, and we're going to go ahead and figure out what the empirical formula is. First step for that is to convert them to moles. So 1 gram of hydrogen is 1 mole, and 16 grams of oxygen is 1 mole. And remember, carry a few decimals so that you don't round too early and end up with a skewed ratio. 6.92 divided by the 16 gets us 0.432 moles. If you look at these are very close. They're almost the same. They're not. So we're going to divide by the smallest number of moles, which is this oxygen one. We're going to get 1 here, and 0.44 divided by 0.432 is 1.018. So this is basically 1. This relationship, this empirical formula is 1 to 1, so it's H1O1. Okay, we needed the empirical formula in order to be able to figure out how many times our multiple is going to be. So you take the empirical formula and you find its molar mass. There is 1 hydrogen and 1 oxygen. We know the mass of hydrogen is 1 and the mass of oxygen is 16. So you get 1 and 16, and when you add them up you get a molar mass of 17 units, or 17 grams. They give you in the problem, they're giving you a mass of 34, and we're going to take our empirical mass of 17, and we're going to see that we need a factor of 2. So the end answer for this problem is going to be H2O2. We apply this to all of the existing subscripts in the empirical formula, multiplying them by that factor. So the end answer for the molecular formula for this problem is H2O2. When you're done, do not reduce this down because you were asked to find a molecular formula, so it would have a multiple.